Welcome to today's Expert Chat. I'm Jenny with the Understood team, and today we'll be talking about dyscalculia. With us today is Daniel Ansari, who is the professor at Western University in London, Ontario. Hi, Daniel. How are you today?
Hi, Jenny. I'm doing well. Good to see you.
Great to see you, Daniel. Thank you so much for being here. Before we get started, Daniel, would you like to tell our viewers a little bit more about your background?
Sure. So my background is in developmental psychology. I got my undergraduate degree in psychology, then did a master's in neuroscience, and then did a PhD sort of at the intersection between neuroscience and psychology. And for my PhD, I actually worked to try and better understand mathematical learning difficulties in children with Williams syndrome. And that sort of sparked my interest in typical and atypical development of number skills more generally. And nowadays, my research program focuses on better understanding individual differences in math development, how that relates to reading. And from a more applied perspective, we're also working on developing better screening tools to identify children who might be at risk early on of developing developmental dyscalculia and other mathematical learning disabilities.
Great, that's fascinating work, and thank you so much again for being with us today. For our viewers, we'll be taking questions. Daniel will be answering them throughout the chat, so please just type them into your chat box. With that, we can get started, Daniel, with I think a really kind of basic question. What is dyscalculia, for those that don't know, and can it be referred to as a math version of dyslexia? We know a lot of people refer to it as that, so can you clarify that for us?
Yeah. So developmental dyscalculia is a learning disorder in the domain of mathematics, especially arithmetic. So children struggle with, being able to encode and retrieve even the most basic arithmetic problems. And we think children with developmental dyscalculia have fundamental difficulties in understanding and representing quantities. That really seems to lie at the core of developmental dyscalculia. So it is called a specific learning disorder in acquiring basic mathematical skills. I think it's useful to compare it to dyslexia because people typically know more about dyslexia than they know about dyscalculia. There's been more awareness around dyslexia compared to dyscalculia. But I don't like the term math dyslexia because dyslexia and dyscalculia are different from one another. Dyslexia is a learning disorder in the domain of reading, and dyscalculia is a learning disorder in the domain of mathematics. And they might have slightly different causes as well. We don't know yet, but I think it's important to distinguish between the two, whilst at the same time acknowledging that they can also co-occur.
Mm-hmm. They do co-occur.
Yeah, they definitely co-occur in about a third to half of children with dyscalculia. You also see that those children have reading difficulties. So there's a high degree of co-occurrence of dyscalculia and dyslexia. And there's also research to suggest that similar genes may be involved in dyscalculia and dyslexia. I think in general, learning disorders frequently co-occur, but nevertheless, it's important to understand what's the math disability part, what's the reading disability part, because understanding those better will inform how we might not only diagnose them, but also develop interventions to try and help children cope with learning difficulties in math and reading.
Important. Okay. And Daniel, why should we take dyscalculia seriously?
I think we should take dyscalculia seriously because we know from a lot of research that individual differences in early basic math skills predict a lot of later life outcomes, things such as mortgage default or salary, income levels, whether you graduate from high school or not. All of those things can be predicted by children's math skills. So, over the past 30 years or so, we've paid a lot of attention to reading. And I think we have a good awareness of the importance of reading. Parents know that reading to their children is really important. With math, it's perhaps less so. And I think it's really important for us to take math seriously and therefore dyscalculia seriously, because we're learning so much more about the importance of early math skills. There's some really nice longitudinal data to suggest that early math skills are the best predictor of later school achievement, and even better predictor than early literacy skills. So that would be my answer as to why we should take dyscalculia seriously.
Right, right. That makes a lot of sense. Thank you. I'm going to go to a viewer question. An anonymous viewer would like to know, how long have we known about dyscalculia, Daniel?
That's a great question. So as far as I'm aware, the first scientific publication that mentioned the term developmental dyscalculia was in 1974 by a Czech neuropsychologist called Ladislas Kos. And he described dyscalculia as a learning disorder in the domain of math of potential neurobiological origin. But I think it's important here to distinguish between developmental dyscalculia and acquired dyscalculia, because the early neuropsychologists dating back to the beginning of the 20th century were already describing patients who, following brain damage, had acalculia. So, but that's of course very different from a child developing difficulties in math. So I would say for developmental dyscalculia, probably it's safe to say that with that seminal paper by Ladislas Kos in 1974, that's when people started to refer to it as developmental dyscalculia.
Okay, great. Marcy, one of our viewers, has a question about assessments. She'd like to know if there are any other assessments other than educational psychological evaluations or markers. So what's going on in terms of assessing or diagnosing dyscalculia, Daniel?
Yeah, so there we are still a little bit behind the work in dyslexia. One of the problems is that currently dyscalculia gets typically assessed by having children do a lot of sums, a lot of arithmetic problems, using standardized tests. And there's nothing wrong with those tests, but they don't really get at the underlying processing issues that children with dyscalculia might have. So there are a couple of newer tests. There's a number sense screener. We've developed a short screener as well that's available for free on the web if you search for numeracyscreener.org. But those are not diagnostic tests. So I think what is really lacking is a good battery of tests that can provide a formal diagnosis of developmental dyscalculia, and also look at processing measures. So look at children's understanding of quantity, how they map quantity into space, things such as number comparison, ordering numbers. I think those more low-level processing measures might be better at identifying children who have real dyscalculia versus those who might just struggle in math for other reasons, attentional difficulties, or simply not enjoying the class very much, which is very different from actually having a difficulty that prevents you from benefiting from instruction.
Right, right. And Marcy also asked a question I think you referred to earlier about whether dyslexia and dyscalculia can co-occur. And I believe that you said that, yes, it is common.
Absolutely,
yes.
Absolutely. I mean, sometimes I think we make the mistake of thinking about dyslexia and dyscalculia as they're sort of very isolated disorders, and, children with dyscalculia are only performing poorly on math. But as is the case for dyslexia, dyscalculic children have difficulties in other domains as well. And I think it's useful for us to think about the co-occurrence of these difficulties. And yes, dyscalculia and dyslexia often co-occur. The search for a common cause has not yet revealed something particularly striking. But as I said, there's definitely genetics data to suggest that similar genes might be involved in both dyslexia and dyscalculia.
Okay. Daniel, are there any studies that have given us especially good insight into understanding dyscalculia in particular?
Yeah, I think one seminal study is by Karen Landau, Bevan, and Brian Butterworth from 2004, published in the journal Cognition. I say that's a seminal study because it was really the first study that sort of considered whether children with dyscalculia have deficits in basic number processing. And so one of the things that they did in this paper is they had a task where children had to compare which of numbers is larger. But so you would, for example, see a 1 and a 9 printed on the screen, but they would also vary the physical size. So sometimes the 9 would be larger than the 1, printed in a larger font size, or sometimes the 1 would be larger than the 9. So then they could ask children either to say which of the two numbers is physically larger, so which number is taller, or which number represents the larger number of items, which one represents a larger quantity. And when they did that, they found that children with dyscalculia did not differ from children without dyscalculia when looking at the physical size. But as soon as they had to access the numerical meaning of those symbols, that's when they were much lower than children without developmental dyscalculia. And that was sort of a seminal finding because it showed that children with dyscalculia, when they look at number symbols, they have real difficulties retrieving the associated meaning. So mapping between symbols and quantities seems to lie at the core of developmental dyscalculia, in addition to other problems as well. I think there's other papers as well. I think one other important thing to consider in dyscalculia is that many of these children have particular difficulties with spatial tasks. So with spatial reasoning, they also have difficulties with visual spatial working memory. And indeed, parts of the brain that are implicated in doing numerical things, doing, for example, calculation and reasoning about space and maintaining spatial information in your working memory, there seems to be an overlap there as well. So I think that's also some really important insights, both from behavioral studies and brain imaging, to suggest that visual spatial processing might be something that children with developmental dyscalculia find quite difficult.
So when you talk about spatial, processing, so, I'm a former elementary school teacher. So Are we talking about like the number line? Like, do children with dyscalculia have a hard time with even the concept of a number line? Is that what you mean when you talk about spatial, or could you give us a few other examples?
Yeah. So one of them would be the number line, and I think working with number lines has been shown to be an incredibly useful tool in math instruction, helping children understand the relationships between numbers and helping them to sort of develop a spatial metaphor for numerical information. But in addition to sort of the mapping of number into space, it's been shown that children with dyscalculia have difficulties with spatial working memory. So, for example, if you see a grid of items and there's different parts of that grid that light up in a particular sequence, and then there's a delay, but you have to remember which items in the grid lit up. You have to maintain that information over a delay period. Children with developmental dyscalculia have very great difficulties remembering that spatial arrangement, the way in which these different items in the array lit up. That's called a Corsi spatial working memory task. And children with dyscalculia typically perform much lower than children without developmental dyscalculia on spatial working memory. Another thing that people are looking at is their mental rotation ability. So, for example, you might see, a three-dimensional shape, and then you see 4 other possible ones, and you have to say which one of these 4 could this shape be rotated into. So you basically have to perform in your head a rotation of a shape that you see on a piece of paper. And I think children with developmental dyscalculia also have difficulties with mental rotation. So, and many people think, even mathematicians have said this, that there's something quite intrinsically spatial about math. The precise links between space and math are quite complex to understand, but we also know that strengthening children's spatial reasoning abilities early can have an impact on their later math abilities. So I think that shows up in dyscalculia, and that children with dyscalculia have problems with number, but they also have problems with basic spatial tasks, number lines, but also those that simply test their mental rotation abilities or their spatial working memory abilities.
That reminds me of an article I just recently read about how, children should really work on their spatial processing, as very young children. So what are some, practical activities that parents can even, or even in the schools, what are some basic, spatial activities that might boost a child's spatial reasoning?
Yes. A lot of educators are working with shapes and, origami type games. There's a wonderful book called Talking Shape that describes a lot of these activities by by a group of Canadian researchers and educators, in which they've sort of they draw on the evidence for what kind of spatial games are the best. So I would recommend looking at something like that, for example. I think there's a lot of work now going into developing better spatial games for kindergarten children as well, to sort of strengthen their spatial reasoning abilities, and in the hope that that will at least to some extent transfer then to math learning as well.
That's interesting. I'll have to check that out. Cass, one of our viewers, is asking for a little bit more clarification, I think referring to the study you talked about. So a person that would have dyscalculia, is it true that they would not fundamentally understand that 9 is higher or larger than 2?
I don't think it's as categorical as that. I mean, I have yet to see a child who can't eventually learn the relationship between symbols such as Arabic numerals and quantities, or number words and quantities, but they are significantly slower and more error prone when they, for example, decide which of two numbers is larger. And if you think about that, that will really impact their ability to then do other things with those numbers, not just reason about their relative magnitude, but use them in the context of calculation. So what we and others think is that dyscalculia is at the very core a problem with processing quantity and linking quantity to symbols. And if you don't have a fluent understanding of how symbols and quantities are related to one another, then you're going to have great difficulties of using those symbols in more complex aspects of math, such as calculation. Okay. So it's not categorical. It's not as though they don't have it, but they have less of a fluency in their understanding of the relationship between symbols and quantities.
Okay, so that would lead me to my next question, Daniel. At what point would you suspect that a child is not, just struggling with math? When do you actually cross over to, realizing that the child might have a true math disability? I mean, lots of kids struggle with math, and I guess there's a lot of reasons that could happen that really don't have anything to do with a learning disability. But how would you differentiate for someone who knows that their child comes home from every day and math is a real chore and a real problem? How would a parent or even a teacher know the difference?
Yeah, that's an incredibly difficult question. It's always the problem when we're dealing with things such as dyscalculia and dyslexia is we don't have a blood test for it. We don't have a genetic marker. So the way that we diagnose learning disorders in general differs quite a lot between practitioners. From my vantage point, and sort of looking at the recommendation of the Diagnostic Statistical Manual of the American Psychiatric Association, the DSM-5, I would say one really important criterion is persistence in the difficulties over time. Some children, as you say, will just struggle on a given day. So if we just give them one test and then say, oh, they performed really low on this test, they must have dyscalculia. If you test them 6 months later, they might be fine or even excel on that test. So it's really important to not just have a single shot approach, but to observe children over time, to see whether they're responding to instructions, whether they're responding to different ways of trying to explain the problem. And if you see a persistent difficulty, I think then you can start to suspect that there's something more than just inattention or lack of interest or inability to respond to a particular form of instruction is a problem here, but that it might be something a little bit more basic, that it might be dyscalculia. So I think being not just having one assessment, but maybe following up and seeing how persistent something is really important. Of course, I know that practically that's often very difficult because it's expensive to get assessments and you don't want to have to do it multiple times. But I think if a child is given a diagnosis of any learning disorder, it's important to follow up over time and to see how persistent that difficulty is.
Okay. Just to go a little further, Daniel, I know we've spoken before with you about math anxiety. Can you talk about the relationship between, math anxiety and dyscalculia? Is there one?
Yeah. It's so mathematics anxiety is very common, and I think many children experience math anxiety, and teachers experience math anxiety too. And in fact, there could be a relationship between teacher math anxiety and student math anxiety. The relationship between math anxiety and dyscalculia is complicated. I think there are some studies to suggest that those who have math anxiety also have lower math skills, but there are also other studies showing that this relationship between math competence and math anxiety is not a perfect relationship. So that leaves open the door to the possibility that there are kids with math anxiety for multiple reasons. You could have math anxiety because you are dyscalculic, and so you struggle in school and it becomes an extremely negative experience for you, and you just want to avoid it. You're not good at this, so you're avoiding it. But you could also be perfectly competent at math, but you have a negative experience. Maybe one of your peers calls you out because you couldn't solve a math problem, or a teacher calls you out, or you have arguments with your parents when doing the homework about math. And that then leads to math anxiety and the avoidance of math. Whilst actually there isn't a difficulty in learning math, it's more just an emotional reaction. So I think it's important to really look for both and to see whether, a child, for example, that has math anxiety, do they really have a fundamental difficulty with math, or is it just that they've had some kind of bad experience and now they're avoiding it? Or do they have dyscalculia, and that also then leads to math anxiety? So I think it's really important to consider the two. It's always important, I think, to consider both the emotional and the cognitive components of anything we look at, really. And sometimes we focus too much on one or the other. We need to look at both and understand that they are very complex relationships to one another.
Okay, great. We have a few more questions that have come in, Daniel. I'm going to try to get to as many as possible. Cass says that, I'm sorry, I'm going to go to A. Sparks. My daughter has been diagnosed with dyscalculia after a long 3-year battle, and it seems that methods of treatment are far behind dyslexia. What methods of help would you recommend, and is there ever a chance that a child with dyscalculia can get to grade level?
So, the individual is absolutely correct in that we're very much behind dyslexia. I think at this point, I don't know of any evidence-based tool specifically for dyscalculia. But I would recommend looking at, for example, the What Works Clearinghouse website of the United States Institute of Education Sciences, and looking for what kind of evidence-based math interventions are available there. I think at this point, you have to just try many different types of interventions, but try to look for ones where there is some indication that it's evidence-based, that its efficacy has been assessed through a randomized controlled trial or through some other scientific methodology. I think that's very important. And sorry, I forgot the second part to the question.
Is there a chance that a child will ever get to grade level, Daniel?
It's difficult to say. I think children with dyscalculia don't necessarily, the one thing we have to consider is that math is very multifaceted. So you could imagine that a child may struggle greatly with acquiring the basic calculation skills, but later on finds things such as data management or statistics quite intuitive and can deal with those things. So I think it's important to never give up and to see, are there areas of interest for the child in mathematics? Do they find geometry more interesting? Do they find statistics more interesting? And to understand that maybe the difficulty is with arithmetic, but it might not be in other domains of math. So there could be aspects where a child could reach grade level. I wouldn't exclude that a priori.
Mm-hmm. All right. So, Daniel, I know, your work is in the research lab. I mean, you're doing research and phenomenal things with brain science. For parents that are inquiring about methods of instruction and intervention, books, programs, can you point them in any particular direction at this point for a little bit more help with their child's struggles with that? Mm-hmm.
I think I should say that I have no affiliation with any of these programs. One program that I think is probably worth looking at is the Jump Math program. Junior Undiscovered Math Prodigies program by John Mighton, and that's actually a charity. I don't think it's specifically designed for dyscalculia. In fact, I know it isn't, but it's a program where I've heard from parents that they've had some success with it. I should say there's no study yet showing that this necessarily leads to greater improvements than other programs, but it's worth looking at. I think the Number Worlds program by Sharon Griffin is a program that has some evidence base behind it. It's difficult for me to point to other programs. Those are two that I think get at some of these core quantity processing issues that children with dyscalculia might have. There is a free online intervention tool called the Number Race, which was designed by Stanislas Dehaene, who's a very famous scientist who's written a great book called The Number Sense, which I highly recommend. But the Number Race is an intervention tool for which there's some success has been shown. And it's free online, so that might be worth looking at. So those are some things that spring to mind. I think for parents with children where they feel that children might have difficulties with math, is also try to do more math in the home. Try to play more math games, do some more activities in the home that might strengthen children's understanding of quantity and quantitative relationships.
Okay, great. Thank you for all that information, Daniel. That's great. We are going to include some links to some treatment options for dyscalculia, including interventions, in our chat box, so you can follow the link there. Daniel, I'm afraid that's all the time we have. This has been such an incredibly informative session. Thank you so much.
Yeah, it's lots of fun. Thank you.
Yeah, and to our viewers, thank you so much for being with us today. If you've missed any portion of this chat or you'd like to watch it again, we archive all of our expert chats at u.org/calendar. Thank you once again for being with us. Thank you for your questions, and have a great rest of the day.